Hi, I'm Phil, and today I wanted to talk about recycling for STEM education. And I'm going to use this mind map, and I'll just walk through some of my initial ideas on the project. What the problem is, we'll just move up here, move the mind map across, and I'm now the CSIRO partner at Chatswood High. And one of the problems the teachers there identified was that recycling at the school is terrible. And perhaps a STEM project where the students put together a game or something to change the behavior of the school so that recycling at the school can be improved. So the inspiration for this came from the school. They identified that perhaps a game and some rewards where a house can get some benefit from recycling cans and plastic bottles and putting them in the right bin might benefit. And the game was the one that they chose. My initial thoughts on this was to look at the whole process of recycling and think about why we should even bother recycling. What happens after we put the bins out? And I think part of the problem is that why does the school have a problem of recycling? Is that they don't identify what happens to the waste after they are put in the bins. What I'm proposing is that we explore the whole problem just beyond the school bins and relate the waste issue to the environment. And one way to do this would be to quantify things and find out how much waste is put in the wrong bins. And that could be used to set some goals for improvement. And perhaps it could also be used to compare performance with other schools and set up those goals. So in the total picture of waste, looking at the school's commitment in reducing waste, reusing waste, recycling, and separating waste, they could also be part of the picture to explore. Now, some of the alternatives, rather than just studying behaviour, other STEM projects on recycling look at how materials are recycled, and they relate that to the study of materials and how you might even be able to identify and separate materials. And this could lead to projects that relate to smart bins and rewarding behaviour based on being able to identify the correct materials and the correct bins. So in a bigger picture, we could look at the way that materials are recycled in nature and how living systems use recycling of gases, nutrients, and this can lead to a more sustainable environment. So a couple of projects I've done in the past relate to compost bins and the use of monitoring when is the right time to empty the compost bin and what is the optimal environment. And I use measurement. I use temperature probes to measure the temperature of the compost bin. And I also use lots of recycled materials in my STEM program, anything from paddle pop sticks to cardboard boxes. I make robots out of cardboard boxes. That's another alternative, is to recycle the materials. Now, just looking at some of the resources that I have, that I've got, I set up a games environment about 3 years ago, based on the Microsoft Arcade make code. So that's a pretty good environment to develop games. So the whole emphasis there is on creating small games that could go onto a game console. And some of the game consoles that I've got, one is the Kitten Bot, Meow and Bit, and it looks very similar to the Microbit, but it's got a nice LCD color screen, and you can put games on that, and it's designed for games. Another choice could be the Adafruit Joy Bonnet for Raspberry Pi, and in particular, it's Raspberry Pi Zero. And if you wanted to go further, there's plenty of icons that you could add to your games. So there are websites for that. Another perspective on the bigger picture is to actually simulate what happens when you recycle and when you don't recycle. And there's an excellent model that's as part of the library of Netlogo that would be worth examining. And another resource that I thought of was to use machine vision and AI and identify if students are putting the rubbish into the right bin. So this would identify both the bin and the rubbish and give students some feedback if they're doing the right thing. And this could also be combined with robotics. So a robot could move around the school playground and just check on how the kids are performing with their waste management. And I guess the other side of it, you could relate the waste with property of materials and separating materials, and that could be another exercise to have a look at. So that's the resources. And a couple of projects. I've been looking at some projects. One is urban studies and recycling. And this project by Netlogo provides a model like this. So you can simulate the good guys are the ones in blue and the bad guys are the ones in red. So the ones in blue have a small plot of land, and they recycle the materials and minimize the need for wasting energy. And the ones in red don't bother, they just throw everything away. And this model allows you to change the parameters and see what happens. So you can look at the impact on land use and population. So quite an interesting model. So it's a mathematical model that uses graphics and coding to come up with a better understanding on waste management. So that's a worthwhile one. And I'm looking at using Microsoft MakeCode Arcade Games environment. And I've played around with some code on this. And for me, it's really a matter of learning the whole environment. But this is what it looks like. It's a blocky type language. And to do a very simple game, you've got buttons on your game console. So there's button A. If button A is pressed, left or right, it can then move the sprite. And so all of the objects, so this is an object-orientated environment that uses games objects, things like background, sprites, buttons, and even the timing relates to games. So for me, this is a learning process. And well, within a day, I started having a look at it, and I got as far as a proof of concept for a recycling project. So this is my recycle, and I'm porting it to a game console called KittenBot Meow or MeowBit. And this is the program that I've come up with so far. And I'll do a separate video on these projects, so I won't go into detail on that now. And finally, we've got the smart bin. And the smart bin, I haven't started yet, but it will use AI vision to identify both the rubbish and the bin, and check to see whether students have put their rubbish in the right bin. So that's projects. And if you're interested in following it up, there are some of my references. Plenty of web resources, and we'll just pull those down. I've got lots of mind maps that relate to recycling. I've got a mind map on KittenBot, and the AI vision is called HuskyLens. A very good resource is STEM Learning from the UK, and they have lots and lots of materials already on recycling. And there are other, so one suggestion would be for students to actually look around and see what's already on the internet. And that's it for the time being. Stay tuned, and we'll have a look at future progress on some of those projects. So that's all for now.